Alright, we are live. Uh, this is going over question 6 of the second quiz of the day. It's titled More Combo Circuits. You can see the questions that are in it. And this is question 6 that we'll be going over. I went ahead and set up the chart before we got into it. I did skip a couple things. Let's do a line right here-ish. Everything down below here is going to be theoretical circuits and not actual circuits. Let me see if I can. It's fine. Make that green. Alright, let's enter our numbers in. So R1 is 1. Oops, on the line tool. Ohms. R2 is. Oh, R1 is 9. 9 ohms. 2 is 11 ohms. 3 is 100 ohms. 4 is 5 ohms. Let's see. 5 is 17 ohms. This is laid out really weird. 6 is 13 ohms. 7 is going to be 4 ohms. And 8 is 8 ohms. Okay. As with all combination circuits, the first thing we're looking for is R total. So we're going to start, and you'll see I have the circuit up twice. That's so that I can combine circuits or combine things together. So our first step, we're going to go as far away from the voltage source as we can, and we're going to combine these three. So that's 2, 5, and 8. We're going to combine those. They're in series. 11, 17, and 8. That's 28 plus 8. That's 36. 36 ohms. So now that 2, 5, and 8 are combined, that will give us so that removes all of that and turns them into one resistor that is R2, 5, 8, which is 36. Oh, I did skip a line. Oh no, 5, 6 or 4, 6. Now we need to combine 4 and 6. I did skip a line, but it's not this one. 4 and 6 combined together, that gives us 18. So that is going to be 18 ohms. And that will remove that line. And R4 and 6 is 18 ohms. So now these two, if you look and trace out the current paths, they are in parallel, a 36 and an 18. So we need to make a line R2, 4, 5, 6, 8. They're in parallel. We're going to do our reciprocal method, which is open parentheses 18 to the negative 1 plus 36 to negative 1. Close it. One more to the negative 1. Let's plug that into our calculator. I can tell you it's going to be 12. The calculator symbol changed recently. That's weird. Plus 36. Close it one more. 12. So 12 ohms. So we can take and delete those two resistors because we just combined them together. And put we have 1 R2 4 5 6 8 is 12 ohms. It is in series with R1 and R7, so we have 12 ohms with 4 ohms and 9 ohms. That's going to be 25 ohms. So that's R1 2 4 5 6 7 8 is going to be 25 ohms. So we recorded that. Alright, and now we can combine that 25 ohms, which is removing all of that, making it one resistor again. R1 2 4 5 6 7 8. That is 25 ohms. We have 25 ohms in parallel with 100 ohms. So that's going to be 20 ohms, but I'll go ahead and do the math for you guys. 100 to the -1 plus 25 to the -1. One more to the -1. So, oh wait, got it. Open parentheses, 100 to the -1 plus 25 to the -1. Close parentheses, one more to the -1. It is 20. And there's no more resistors to combine together, so that is our R total. So R total is 20 ohms. Oh, and E total is 60 volts. Now R3 and R1 2 4 5 6 7 8 are in parallel, so they both have the same voltage, which is 60 volts. So we have 60 volts, and down here we're going to have 60 volts. All right. So let's start out. Now we can go ahead and complete out some of these lines. So let's go ahead and do that. Let's do these top couple lines. That's 60 divided by 20. That's, I did times, hang on. 60 divided by 20 gives us 3 amps total. So I know our amperage will not be above 3 at any point, because it's all going to add up to be 3 amps. Now we have 60 divided by, oh, I put that 60 right there in the wrong spot, because that's R3, not R1. That's not the brush I wanted. So that our E3 is going to be 60 volts. Alright, now we can 60 divided by 100 is going to be 0.6. We got 0.6 amps there. And since there's two legs, I can tell you that this one is going to be 1.4 amps. But I will also do it in the calculator. So this is that big resistor, or the multiple resistor combined. 60 divided by 25. 2.4. Did my math wrong in my head. This is why I do things in the calculator, so I can be wrong. Alright, so now two, 4, 5, 6, 8. And you'll notice I'm not doing the powers yet because they can be done at a later time, because they're not vital to solving this. Okay, so we need to go take a step back and redo this circuit. So we're taking a step back into one leg with 3 resistors in it. So we have R1, R2, 4, 5, 6, 8, and R7. These are all in series, so they're going to have the same current. So whenever you split things up, it had 2.4 amps before, it's going to have 2.4 amps now. R1 has 2.4 amps, and R7 has 2.4 amps. Now we can multiply on out. You can see we're kind of just working it backwards now. I don't have a spot to put my calculator that's not covering something up. So let's do R1. 9 times 2.4, 21.6, and these 3 should add up to 60. So let's come up. 4 times 2.4, 9.6 volts. And then finally, the very bottom one, 12 times 2.4, 28.8 volts. Let's see, that's over 30, 30, just about 30. Okay, yeah, that should be right at 60. All right, so now R1 and R7 are solved, and I'll put some yellow marks. R1, R7, and R3 are done. So now we can split the 2 R46 into these 2 parallel resistors, R46 and R258. Oh. Oh, wait. And R258. So current or voltage stays the same in parallel. So when we split these, we're going to be using this voltage down here, that 28.8. They'll both share that 28.8 volts and 28.8 volts. So now we can divide 28.8 by 36, get 0.8, and these two should add up to 2.4. And then divided by 18. This should be a much higher number, 1.6. This will come up in a few minutes in the next quiz, but you can see, and I'm pointing at the screen like you could see what I'm pointing at, but you can't. So you can see that the parallel leg with double the resistance has half the current. That is a that is a point of the voltage and current dividers. Parallel legs with twice the resistance have half the voltage, or half the amperage, and will have half the power. Okay, so now we can split these up. Our 4 and 6 were in series, and our 258 were in series. And we're basically going from this back to the full-on circuit, so I'm not going to redraw it one more time. But 258, since they're going to series, they keep the same amperage, so 0.8. So R2 gets 0.8, R5 gets 0.8, and R8 gets 0.8 amps. And then our 4 and 6 gets 1.6 amps and 1.6 amps. Now, if you were just trying to answer the question on the quiz, you would be done because R5 has 0.8 amps. And I can see how you guys did in a second. I'll go look at a report. But 11 times 0.8 should be, what, 8.8? Okay, that's 8 volts. 17 times 0.8. 13.6. 13 times 1.6. 20.8. 8. Oh, it looks like I wrote 0.8. There. 8 times 0.8. 6.4. That's an eraser. Yeah. So that's all of them combined. And if you wanted to double check yourself, multiply out to power. How long have we been doing? 20 minutes? This is why I skipped this one. 20 minutes for one question. It would have been over an hour for that lesson. Anyway, you can multiply on out and get all your powers. And powers 1 through 8 should add up to your power total. And there won't be any of this. Let's see, 2, 5, and 8 should add up to 28.8. We can do that. If I get my screens right. Let's see, 2 is 0.8. Oh, wait. Clear. 2 is 8.8. 5 is 13.6. And 8 is 6.4. That should give us 28.8. And then 4 and 6 should also be. So 4 is 8. Well, 4 is 8 and 6 is 20.8. So 28.8. Alright, so that's this one done. We've solved it. We've checked our answers. And the actual answer that they were asking about was 0.8. Let me, while I've got you, I will check the answers for the last one. Let's see, reports. Resistance in combo circuits. More combo circuits. Question 6. What do we get? Nobody got it right. 92.65 volts. You only had 60 volts to start. That's not right. Yeah, so 0.8 was your answer. I think I saw an 8. Yeah, there's an 8, so maybe somebody just didn't do the decimal. We can look at the reports from last time y'all did it. See how y'all did. Hey, there's a 0.8. Good job, whoever that was. Let's see. Lucas West did it. Good job, Lucas West. Alright. Well, that's all I have. See, a handful of y'all aren't done with today's quiz. So, I will see you guys in the next one. Alright. Bye.